Hi guys, this is my first YouTube video. Um, I will be creating a channel which can help you learn about science, STEM, technology, engineering, mathematics, all that. Today's topic will be waves. So let's get into it. So, as you can see the first slide as waves. This is our title for today, and then we can go into our second slide. This will be what we're going to try and accomplish today. Today well, we're going to try and accomplish to identify the two different types of waves, give example of each type of wave, be able to create examples of the two waves, understand the use of the two of these waves, and yeah. So let's start with this lesson. So you may be asking to yourself, like, what are these waves and how do they relate? So waves. So think about like the word waves. What first comes to mind? It may be like the ocean and like whatever earth waves are. But like they're not the waves we're going to be talking about today. Today we're going to be talking about waves like sound and light. Even the even that microwave you use every single day in your kitchen, it uses waves. Microwaves. Isn't that isn't that funny? Microwave. So almost everything we use is almost used with waves. Think about your phone. Your phone uses waves. Your iPad uses waves. Any electronic device, it uses some kind of radio wave. Even the heater you have in your house uses waves. So a lot of things in your daily life probably use waves. But yeah. But the official meaning of wave, just to clarify, is a disturbance that travels through a medium from one location to another. I got this quote from physics classroom. If anybody wants to, please do check them out though. A key thing to remember about waves though is that they vibrate, but they don't move. Unlike the ocean waves, well, they don't even move then. The waves don't actually move. They just vibrate in like a way. So they may vibrate up and down like in a pattern like that, or they may just stick together like that, but or even like that. So waves can use a lot of different patterns. But the thing is, there's no mass transferred. No object is moved, no mass is transferred. Only energy is transferred. Okay, there's a key thing to remember when you're learning about waves, that they only transfer energy, no mass. Let's look at the types of waves. Well, there are two main types of waves. Those are transverse waves and longitudinal waves. These two waves, they are very important. Well, obviously important, but yeah. So let's see what they are. Transverse waves. So these waves actually, they vibrate perpendicular to the direction of energy transfer. And so imagine if like the energy transfer was this way. So like perpendicular, it means like at a right angle to something like that. So if it was traveling this way, the vibration could be this way or this downwards. It could be downwards or it could be upwards. So that is how it would normally look. And you can see here that a transverse wave only normally goes like this. Okay. An easy way to remember this is to look at the word tra, the prefix tra in the word transverse. Tra, it kind of looks like an L shape if you think about it. And that L shape is a right angle So you can think of that way, but yeah, it's your choice. But I would recommend using this way. The higher part of this wave is called the crest. The lower part of the wave is called the trough. This is just how, like, this is just random names they've been given. And one thing to remember with looking at these two is that, do you see that middle line in the middle? That is the equilibrium, as it's shown in that picture on the bottom right. So you have to think about, and also on the top picture, if you think about the top right picture, it says something about amplitude. That is the difference from the crest or trough from the equilibrium. That is the amplitude. You might have seen this in like music or something when if you're a musician. Maybe if you're like playing guitar or something. You may have seen amplitude. That is like how that just shows you this. So one wavelength is one crest and one trough. But you may see in the top right picture that in that top one wavelength thing, it has like half a crest and half a full trough and another half of a crest. That is still right, even though it's only half and half, because it makes one. That is why it's right. But key exam, so though that is what transverse waves are, end to end. But a key examples of transverse waves are seismic S waves, tidal waves, and radio waves. There are lots more, but we're only going to talk about these ones because they're the easiest to remember. Anyways, now it's longitudinal waves that we're going to learn about. This is the other type of waves from transverse waves. These waves are different from transverse waves in the way that, you know how transverse waves vibrate perpendicular? These vibrate parallel. If you don't know what parallel means, that means that they are straight line, and if they went on forever, they would never touch. That means they're straight, and they are at such an angle that they will never touch, no matter how much you go on. And that is what parallel means. But unlike transverse waves, which like have that weird wavy like stance, these are more like straight lines. It may not show in this picture because this shows the picture on the right, on the left, sorry. Yeah, on the right, sorry. It shows a slinky being thrown. That isn't a slinky is a very good way to show waves, but normally you would see it as a diagram as straight lines. Okay. So that is what longitudinal waves are. And in longitudinal waves, you know how in transverse waves they had like crests and troughs. In longitudinal waves, they have compression and rarefaction. So think of the compressions like there's only straight lines, yeah, in the whole way. So there's a straight line here, 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 there's a straight line here. The straight line here, and the straight line here, and the straight line here, as shown on this picture on Slinky. The closer the straight lines get, that part is called the compression. The further they get, when they are far away, that part is called the rarefaction. One compression and one rarefaction create one wavelength. So compression and rarefaction are basically the longitudinal versions of trough and crest. Yeah. So now we can think about the examples of these waves. There are actually lots of examples of longitudinal waves. Like, look at your sound waves. All that speaking that I'm doing is just transmitting that through these kind of waves. Ultrasound waves. These are like slightly above like human hearing, etc. seismic P waves. These happen before like earthquakes and stuff. Now let's go move back onto transverse waves and let's look at their properties. So transverse waves properties are quite diff. Well, they are quite well. Maybe you know them. So let's think of the examples of the transverse wave. What examples did we have of the transverse wave? Light. Light is a key example to look at because think about light. This can tell you all of like the properties of a transverse wave. So light, it can travel through a space where there's vacuum. So that means it can travel to space. Space has a vacuum. There's no medium. By the way, medium means like a state of matter covering that area, but there's no medium. That means it can just travel through, even with no medium. But it stops at opaque objects, as you may know. Like look at the maybe a piece of wood. Light cannot pass through, can it? Neither can any other type of transverse wave. But they can go through vacuums. Okay. So that is a key thing to remember when you're thinking about transverse waves. Their properties are really important. For longitudinal waves, their properties are the exact opposite of transverse waves. So they can go through opaque objects, but they can't go in vacuums of space. This is why have you ever heard of the theory that you wouldn't be able to hear a scream in space? That is correct because sound is a type of longitudinal wave. It passes through. It can't pass through a vacuum. Space is a vacuum, as mentioned before. So you wouldn't be able to hear anything in space. It's just silence. That brings us on to the usage of waves. And now that we've covered all the properties, now we need to understand the usage. So waves have two main roles. They fill one of these two main roles, okay? Transferring energy or carrying information. So transferring energy, think about like light. Light transfers energy by moving. And don't think these are like only transfers waves fit in like transferring energy, only like longitudinal waves fit in transferring energy. This is a completely different thing. So they both can mix about in this thing. So transferring energy, even sound transfer, which is a longitudinal wave. Well, for carrying in, there's another way to do it is carrying information. So you know how you use your phone every single day, that Wi-Fi. Wi-Fi is a wave. It is a wave which carries information to your phone so that you can log on to like the internet, etc. The rules. Now we need to think about the rules. If we learned about the usage of a wave, we need to consider about the rules. Cause think about this. Like only energy can be transferred in a wave. It's like, have you ever seen that show where they like just imagine you're just moving a battery? That could be called a wave. But there's one thing which stops it being called a wave. That is the part where it says mass cannot be transferred. When a wave is done, when a wave happens, only energy is transferred. Mass is not moved nor transferred. Only energy is. This is one key thing to understand when you think of waves. It is very key if you wanna maybe do physics for GCSE. No, GCSE, sorry, A levels. So that was all about waves. So let's get to the conclusion. In conclusion, like all that we've discussed, there's one key thing that you need to remember. Two key things. Well, First is that a wave is a vibration of particles which creates a disturbance carrying energy with them, but no mass is moved with it. Sorry, but no mass is moved. And there are another thing is that there are two types of waves: longitudinal and transverse. Transverse waves, as we discussed before, they are perpendicular to the energy transfer, and longitudinal waves are parallel to the energy transfer. Well, vibrate parallel to the energy transfer. This is one thing you must remember about waves. But yeah, that was my video. Be sure to check out the exercises below because they may help you refresh on these topics. But bye for now, and remember to like and subscribe.